Traditionally, video is a product. You record some stuff, edit it, and work very hard to make a finished product, an output. But there's a drive to make everything in the world understandable by computers, and therefore able to be processed. As a result of our great progress in collecting and analyzing data, you can type into Google a few words from a song that you just heard and find out the name,
In the
listen to it
sun,
again, watch
like
a
in
music
a
video,
lovely,
or even
it
an
was us
interview with the
against the
singer.
world.
I first decided I would.
It's easy enough for computers to process data if you're just parsing text, because text is closer to the native language of computers, ones and zeros. That is to say that all the information within a computer is really just a series of two states, which we call 1 and 0. So if you want to represent any more complex kind of information, you need to come up with a way to encode it using just ones and zeros. Pretty early in computing, it was decided that strings of bits of zeros and ones could be used to represent common symbols such as the letters A through Z and digits 1 through 9 that are in common usage in Western written language. For example, the string 10000001 represents the capital letter A. 1001101 represents M. This code is known as ASCII, and it's very old. Because the history of encoding text goes back so far in computing, it's a long-established base level kind of information. Thus, channels for passing and processing text within machines are much more well established than other kinds of information. Mobile video has a lot of promise as input to smarter systems. Rather than undertaking the slow process of typing text into a computer, wouldn't it be nice if we could capture data 24/7 by just looking around while wearing a camera?
All right, we're gonna head over to the creamery, grab a cup of coffee. So we're gonna ask Google Glass for directions. So I just stop here and say, okay, Glass, get directions. The creamery. So the turn-by-turn directions pop up. I can look at the whole route, or I can just let it guide me. So we'll move on.
At this point, computers are just barely able to process video information to get usable data to feed into other systems. One way to allow us to use the data in videos is to convert it into text so that computers do what they're already good at, parsing text. And since computers can still be really dumb, they still need humans to do some of the data entry work. For example, YouTube asks you to add metadata, data about the video that you're uploading. This type of data is referred to as authored data. YouTube and computers in general aren't smart enough yet to summarize your video or give it an appropriate title. While it might be able to assign tags, they probably wouldn't be very good, so YouTube users do that part as well. YouTube chooses a few thumbnails for you to choose from, but it also lets you upload one because it really just has no clue which of the many images in the video best represents the file. This type of data is helpful because that's how users look for specific videos. They're used to thinking in keywords. When you use YouTube or Flickr or other services, there's also some information that is generated automatically. For example, since computers are so good at understanding or parsing text, one tactic that developers use to digest media is to convert that media to text where possible. So YouTube has been pushing forward with auto-captioning videos that are uploaded. This creates a text description of the audio in the video. Not only does this allow the videos to be viewed by hearing impaired viewers, but it also allows the videos to be more easily translated to whatever language. The translations, like the captions, are of questionable quality, but it's zero effort on the part of the video owner and probably better than nothing. Adding this caption metadata to the video allows YouTube some ability to make rough generalizations about content. For example, some users have been frustrated because their videos were being hidden from other users in safety mode based on mistranscribed captions. So for example, a word in a gardening video gets mistranscribed as sex, and the video is hidden from viewers in safe mode. While YouTube doesn't yet use GPS data that can be synced up with video footage, many smartphones record data along a global positioning grid, and they'd attach it to images and sometimes video. Google Plus uses what's called EXIF GPS data to track where photos were taken, which combined with user-entered data helps Google show relevant photos with searches. Some specialty cameras track GPS data and can help you create a video that pairs your perspective with that GPS data. Some even use other sensors like a heart monitor or bike computer to provide a dashboard full of metrics about your trip. So we're seeing increasing use of automated and authored metadata being synced up with video so that computers can better understand what's happening in video. and serve it up to you when it thinks it might be relevant to a search you're performing. But can video itself be used as input that can be parsed by computers to fulfill some goal? The answer is yes, but it's still rudimentary and growing out of image and audio recognition capabilities. A video file contains a lot of data, and it would be difficult to sort through it all. But just as with any complicated process, computers break down the process into chunks. So let's look at how a computer sees video. Let's consider this video here. This video is made up of two streams, video and audio. The visual part of the video signal is broken down into frames, which you can see as still frames. Here's an example of early experimental photography that shows how frames, when played in quick succession, can appear to be video. You may have seen animated GIFs, which use the same concept. The more frames per second, the more continuous and bright a video looks, which is why animated GIFs look grainy and movies look bright and flashy in contrast. Usually computers use low frame rate video to process because they can get the gist of what's happening. Fewer frames mean less data, so it's easier to parse. Video has frames, and then frames can be broken down into pixels, the smallest region of a frame. Each pixel of an image will have one color value. It's like post-it notes in these images. Each post-it note would represent one pixel, because it's the smallest unit of that frame. The more pixels in a frame, the more data. So when video is processed, it's being broken down into frames and pixels. Then, for instance, it can be parsed by software such as Manywear, which turns your iPhone into a security camera and sends you a message when pixels in one frame vary from the next, which indicates movement. You can even use the concept of pixels as you mask out certain regions that are likely to create false alarms, for instance, a bird moving around a cage on the side of the frame. And then there's the audio soundtrack of the video. Audio can be represented by a waveform, and each unique sound has a unique waveform. So when YouTube wants to know whether the information you uploaded contains copyrighted material or not, it doesn't pay its employees to watch the video and then check it against a video and audio database. Its Content ID system parses the frames, pixels, and waveforms to create a fingerprint, a representation of all that image and audio data in ones and zeros that computers understand, and then it tries to match that fingerprint against its Content ID database. And it encourages content owners to submit their media to its database by offering the ability to get compensation for copyright infringement. So, given examples like Manything and YouTube, we're beginning to see video being parsed without human intervention. All it takes is a framework for breaking the video input down into understandable bits and then a database to compare those bits with. But where's all this going? Are we here yet?
Welcome.
Not quite. This version of augmented reality, placing a layer of information over visual data, is just a projection of where we might go once computers can identify what we see and then overlay relevant information on top of it in real time. But we're getting close with augmented reality, in ways that might be a little scary.
Hi, this is Kevin from Facial Network, here with a second demo of NameTag on Google Glass. This is the new 2 GB version of Glass, and we're going to demo our facial recognition app, NameTag, for you right now. Okay, Glass, NameTag. So we took the pictures from our first demo and put them up on the wall here in our new office, and now we scan them all the time just to test. And as you can see, the searches are incredibly fast, under a second in most cases. We are connected with the Wi-Fi here in our office. We are using our new facial recognition compute cloud that we've developed over the last
The Google Glass allows us to approximate this reality, but it still needs human intervention, and that you need to tell it what in your frame of view you want it to focus on and scan. Also, you could see in the name tag video that the user could only identify photographs. At this point, name tag is having Glass take a picture and compare that frame against pictures on the internet. But the limitation here is that you have to do the work of lining up the photograph in Glass's target area so that the match can be made. And you can see that it doesn't work every time. You have to get the alignment right. We're not yet at a point in time where you can walk around with a Google Glass and look at a photograph from any angle. In general, you want to see a photograph head on, which is what the computer is going to be looking in the database for as well. Computers can't accurately identify a person from video footage at an arbitrary angle, though some systems can make an accurate guess given a list of available choices. In general, we aren't there yet, which is why the FBI had to turn to crowdsourcing to identify the Tsarnaev brothers, even when they had video footage that linked them to the Marathon bombing. But programmers are getting closer all the time. In the future, we'll see more video footage becoming more and more parsable by computers. But I think we'll also see more backlash against devices that record people's actions. There's already backlash against Google Glass because it takes for granted that people don't care about the possibility of being recorded and their privacy. So what do you think?